Let me introduce this to you today. A three-phase electric energy meter field calibrator. This is the host of the three-phase energy meter on-site calibrator. Here are the accessories. This is the voltage line. This is a current line. Photoelectric head. Pulse line, USB flash drive. Pliers. Taking current. 3 pliers. A BC charger. Function introduction of wiring panel. External power supply, 220 volts. Power switch. It has 3 files. The first gear is an external power supply. 0 gear is shut down. Second gear voltage terminal. This is the voltage terminal, ABC0. 3-phase or 4-phase is OK. Pulse interface. Communication interface. Current clamp interface, ABC, yellow, green, and red, U-disc interface. Charging port. Battery switch interface. Correction ring interface. Current through interface. Yellow, green, red, ABC. Conventional, 3-phase 4-wire energy meter calibration. Only the following 3 accessories are required. Voltage line, current clamp, pulse line. Now let's pick up the wiring at the end of the instrument. Instrument terminal wiring, connect the voltage line first. Voltage, terminal. There are 4 interfaces on the voltage terminal. ABC0, yellow, green, red, black. Corresponds to the yellow, green, red, and black on the instrument. Correspondingly, press directly and press down. Voltage line connected. Pulse line. Pulse interface. Anti-accidental insertion. Current clamp phase. Yellow. Corresponding to the yellow interface A of the instrument. B phase green. Hanger red. Instrument termination complete. Perform table termination wiring. Table terminal wiring. Meter terminal. Terminal, block. ABC0, yellow, green, red, black. Current, current in and out. Current in and out. Let's connect the neutral end of the meter first. A. Phase. B. Phase. C. Phase. Voltage wiring complete. Connection current. Current clamp outlet. The outlet end of the meter. We're connecting a phase current clamp. B-phase current clamp. Connect B-phase current outlet. C-phase current. C-phase current outlet of the meter. Attention. Pay attention to the direction when taking current. The wiring method of the current is to connect the meter. Qualify. The outlet of the meter is connected to 1 or 3 ports. Did we pick up a thick line? For thick lines, the current is going. It flows from the top down. Pay attention to this plier watch. Positive square, sign negative. Positive, negative, plus or minus. Current connection completed. Take power pulse. Power pulse has 4 clips. 2. Black, universal. 1 yellow, 1 green. Yellow plus table 1, or active. Green plus table 2, or reactive power. Find the commons for the meter. Active power of yellow power meter. Pick up the pulse. Instrument boot. Hit second gear. It takes about 10 seconds for the instrument to turn on. Enter the system. Boot, normally. After normal boot, there is a voltage display on it, and the current display is displayed at an angle. Active power, reactive power, apparent power. Hexagonal diagram phase, sequence frequency table, 1 error, table 2 error. Now we only accept table 1. Wiring complete. The error has come out, because ours is an average number. So there is an error here, and it is not correct. Okay. The third error is correct. Meter parameter setting. Find the parameter box on the instrument's action sheet. Click to enter. There are 3 ways. We usually use pulses. Select the pulse mode to enter. First, we choose a current input method. Current input method. It has 5 amp terminal, 5 amp pliers, 100 amp pliers, 500 amp pliers, 1000 amp pliers, according to the current clamp used in the field, or go through the terminal to select the gear. Currently, we are using 5 amp lead. Choose 5 amp lead. Click and click. Let's go to the next column. The second column is the ratio. We normally check the ratio column twice. The second time is 1:1. If you need to calibrate a high current. When we use high current pliers, set according to the ratio of the transformer. How much to 1? How much is 5? Set the transformation ratio of the transformer. Average number. The average number is based on the number of pulses in the field. Normally, we are 2 averages. The number can come out. There's a pulse pattern down there. What about the pulse mode? We have full wave reactive power, fundamental active power, fundamental reactive power. Kibo is in, the full wave is in. We usually use full wave active power. Selecting the full wave active constant. Constants matter. The constant is the constant corresponding to the electricity meter. The constant of the meter is an active power constant and a reactive power constant. What we call active error. Just fill in the active power constant. If what we call reactive power, the unit has changed. We were kilowatt hours just now. It's a kilowatt hour. Please pay attention to this. The number of laps is based on the amount of power on site. How many pulses are coming to set? The more pulses come, the more laps. The fewer pulses come, the smaller the number of laps. Our current table is a constant of 800. So its number of laps is relatively small. The number of pulses is relatively small. We set it to 2. Return to exit after setting up. A storage export of validation data. What about validation data export? Must go through USB stick. We have a USB stick here. The instrument comes standard. Plug this USB stick into the USB port of the instrument. Then, in our instruments, the main interface finds the storage function. What about the storage function? There are many parameter settings. Below is a marketing interface parameter. What about the marketing interface parameters? Mainly for one of the Southern Power Grid. An upload from the marketing system. There's a person in charge number. Mainly according to the number of the person in charge. Bottom data. Now, we don't have a marketing system here. Create a simple data storage system. In the asset number here, we lose 1. Enter any number, 0, 1. Store the data in the instrument. Data stored. We check in the query box. The data we just stored. You can query the data just stored above. Let's take a look at the electrical parameters just stored. Corresponding to the data just now, return. Do a result dump to USB stick. Data dump completed. We can unplug the USB stick. Plug it into the computer and read the data. The meter verification function mentioned above. I gave you a rough overview. Other auxiliary features operate by themselves. If you don't understand, you can read the manual. The technical parameters on the manual are explained.